Firstly, thank you so much for the invitation to be here. I'm absolutely thrilled. As Reid mentioned in his talk, one of the projects we have done before looked exactly at the issue of articulating different methods for studying learning environments and learning interactions. And so we did a project together, a large community of folks, around 30 researchers, like a kind of workshop like this. We got together and formed cross-team collaborations to look at new data together. And so we hoped out of that, we would each bring our insights from our methods and produce something new together. And so I like very much the framing, not only to share methods, but also to try to combine methods. And so it's kind of a personal passion for me to look at how we can do that. With that, a little bit about me. My training is in mathematics and learning sciences. So I was in mathematics first, and then I was studying mathematics at Berkeley and started working with the research group of Alan Schoenfeld about mathematical problem solving and issues of learning. And as I started trying to think about how to describe processes, I was very interested in like video, something you could record on video, the process of learning. Process of reasoning. I started becoming aware of the methods of Andy DeSessa and his work with sort of the nature of knowledge in reasoning about physics. And those ideas, were not so used within the circles of mathematical reasoning. So my first project was trying to think about how to take some of his insights on the importance of intuitive knowledge in physics reasoning to mathematical contexts, but then to try to abstract out of that, what is the method that Andy is using to analyze his data? What is the method, as they began to think about learning in physics contexts, what is involved in that kind of method for studying? So I had to do a lot of work to articulate that. Andy and I ran a seminar together trying to articulate knowledge analysis. So it's a method that's been used for a very long time, but we're actually at the very beginnings of the process of trying to articulate this way that many people across many different studies have analyzed their data and describe its general features. So the work that we did with Reid was a big push towards that project. For the chapter you read for today was our first kind of chapter where we lay out across all of these different domains in which people have been trying to explicate, the content and form of knowledge. What are its principles? So I'm looking forward to trying the general framing out with you. And in terms of what I'll say today, it's a bit of a mixed approach to the task of giving you the principles, but also showing some specific examples. All right. So at the very general framing level, knowledge analysis is concerned with studying the content and form of knowledge for the purpose of understanding learning. So like I said before, reasoning processes and learning, that's how we orient ourselves. What would be a useful way to describe what somebody is using in a learning context? What kinds of descriptions might we give about what they are drawing upon as they reason? So knowledge is this extremely important concept in education, yet it's a very contested concept. It's a very contested term. What would we say is knowledge? And I notice even as I'm looking at the slides, I say, what is the right way to characterize it? I would cross that out. I would say, what are some productive ways to characterize what people draw upon in order to understand how they learn? So, in terms of the roots of the method, it comes out of a kind of two very different lines. On one hand, clinical methods talking with children from Piaget's work, trying to uncover how do children think about various topics, just ask them about it, not coming to kind of presuppose how people think about things, but it's a valid thing to do, to just sit down and explore together a topic and find out their ways of thinking. So, a clinical interview approach coming from Piaget's work. On the other hand, we're very interested in processes of learning and very fine descriptions of the process, and at least in an ideal sense, de Sessa's 93 paper is much more explicit about this as an eventual goal. He saw that program as being in the direction of a computational version of Piaget. Computational, like a genetic epistemology, was his original program. And as we've gotten into the studies, I think many people have moved away from that as orienting their research program, but it is in the background for us in terms of some of the ways we talk about modeling learning events. So we're interested in thinking about different ways we might describe knowledge. So some of the reasons why this is important and subtle is that, in the 70s and 80s, we had kind of new tools for studying knowledge provided by, Cognitivism. And we came to understand, that students come into school with all sorts of really important understandings about the physical world, and it's very consequential for how they reason. But what do we do with those intuitive understandings? Is that a valid thing to call knowledge? If you take a perspective that knowledge has to be justified, true belief, then those types of understanding just are not something that we would call knowledge. But yet, de Sessa's work really pointed towards the importance of thinking about those intuitions and studying their structure and property and how they exactly play into reasoning as definitely something that deserves a lot of attention. It's very consequential for learning. So to give just a quick piece of data that kind of illustrates this or was sort of motivating from the beginning. So this is a famous one that Reid has come back to. He knows this data very, very well. De Sessa studied a clinical interview with a student, Jay. There was many hours of tape of them discussing sort of how various topics and mechanics work. And so this is one, he's asked her to describe the motion of the ball tossed vertically in the air. And so this is her first description, or an early description. So she says, not including your hand, if you just let it go up and come down, the only force on that is gravity. And so it starts off with the most speed when it leaves your hand, and the higher it goes up, it slows to a point where it stops, and then it comes back down. And so, but the whole time, the only force on that is the force of gravity, except the force of your hand when you catch it. And when it starts off, it has its highest speed, which is all of its kinetic energy, and when it stops, it has all of its potential energy, no kinetic energy, and then it comes back down, and it comes back down and it speeds up again. So that's her first description. And so part of the method that de Sessa used was related in a way to this principle, I think, about redescription or asking people to focus or at specific points in their description. So he asks her what happens at the peak of the toss. It kind of refocuses her attention, just on what's happening at the peak. And then she gives a pretty different explanation of the toss. So, air resistance, she starts out there. When you throw the ball up, it's the air. It's not against air because air is going every way, but the air force gets stronger and stronger to the point where it's equal. So it's like an equilibrium for a second. It's not going anywhere, and then gravity pulls it back down. But when you throw it, you're giving it a force upwards, but the force can only last so long against air and against gravity. Actually, probably more against gravity than against air. But so you give this initial force, it's going up just fine, slower and slower, because gravity is pulling on it and pulling on it. And it gets to the top, and then it's not getting any more energy to go to the top. You're not giving it any more forces, so the only force on it is gravity, and it comes back down. So maybe with other types of experience, we have more access to well, I'll save that for a bit. I want to just go back to the point here. The point at hand is, before the moment where he asked her to talk about the peak, she gave a very normative, competent physics student's explanation of the toss. The only force acting on the ball was the force of gravity. Now, when he asked her to think about the top, she went into a different description that, in fact, other physics education researchers at the time had called this impetus force misconception, that there's this competition between this force that your hand gives the ball at the beginning and gravity, and that it dies out over time and then they balance each other. So she changed her description of what was happening in the context based on the follow-up. And so this illustrates, this phenomenon was what kind of captivated DeSessa early on, the fact that that this is a very shifting thing, that we can't just ask one question, expect, yes, that is totally what they understand about ball tosses, enough said, we go on, we're good. It's that actually, if you keep talking with people, you ask them to describe it again, you focus them in on some specific aspect of it, they will reformulate on the spot their description. And so this was a thing that, for somebody in education, if that's happening, I mean, not asking somebody about it is not going to change whether or not that's really how they're thinking, or that's a possibility for how they're thinking. It's consequential that this could happen. And so from an educational perspective, we can't just label that the first explanation as their true understanding. And yet the second explanation given in the literature for the incorrect reasoning, the impetus force, was a little bit unsatisfying, because then what do you do with that educationally? Do you just tell them they're wrong? And then they say, oh yeah, you're right, I'm wrong, and now I think about it correctly. So the kind of replacement model is pretty untenable as well. And so DeSessa's hypothesis was that in the explanation she was giving, there were these, he deconstructed this explanation actually into 6 what he came to call phenomenological primitives that actually were potentially productive elements of reasoning that you could understand why somebody would activate them when they're thinking about the toss, for example. So this kind of body of work that was done with these interviews, very much like that one, birthed this construct of, instead of thinking about large-scale, theories that students have that we can just argue with them about and hopefully convince them to do away with, it's more productive to think about the reasons, the intuitive reasons why they might be saying what they're saying, or thinking in the patterns that they do. And so he proposed this construct of a phenomenological primitive. It's something that in the moment is self-explanatory. It's not something that, it does the work that the person needs at that moment. It explains to them how and why something is the way it is. And he hypothesized that there are many of these, and like in that explanation, they get kind of recognized in concert. They arise originally from schematizing experience, so they're something coming from. They're not learned. They're something that comes from your experience, and that even in the earliest paper, he talked about the recognition language for these is very hard. They're inarticulate. Sometimes, we as analysts will give them a gloss or write a description of them, but that's a kind of poor approximation to some of these phenomenological primitives that are rooted in your bodily experience in the world. So he's very aware, even from the beginning, that p-prims are a model, and there's a difference between our description as analysts and the felt experience of the individual. But it's a model that has some different implications for what you would do educationally than some of the other descriptions for knowledge out there. So one very common example of a p-prim is what is called Ohm's p-prim. So there's an effort, some resistance to that effort, and then a result. So like more effort gives more results. So if we push things harder, they go farther or faster. It's this kind of simple idea that you see applied all over our lives. You know, bigger weights result in a less result, so it can go in the inverse direction as well, or even in a, you know, more abstracted from the like physical experience. If we work harder on our homework, we can get it done more quickly. Or this kind of pattern of relationship between effort and result is, he hypothesizes, this P premise kind of behind that. And so the perspective on knowledge that is being developed through the idea of P-prims, that's a very specific knowledge system. It's what he called the intuitive sense of mechanism, your intuitive sense for how the physical world works. But knowledge systems, more generally, proposes are you know, made up of all of these different elements of different form and function. And when, you know, you're first learning at a domain, the elements will be very loosely connected to each other. You might, you know, just recognize them in a less articulate way. It's more immediate, like a P-prim is something that's just recognized in the situation. But as you learn, the organization of the system becomes more structured. There are more well-defined subsystems, and so in the end, you know, you've got, like, instead of the fragmentation that you see on the sort of naive state, somebody who's very competent in a domain has much more complex organization to their knowledge system. And so this is, you know, a debate in conceptual change about, you know, is students' intuitive knowledge fragmented versus coherent, and that debate has gone for a long time. We're on the fragmented kind of side of that debate, and that it's not to say that people don't have a lot of, cannot exhibit some sort of coherence, but that's something that's hard won, takes a lot of time, and is sort of an outcome of the system as opposed to like a initial state. All right, so just to keep the image in mind that we're thinking about a system that is becoming increasingly organized as people learn, is sort of becoming tuned toward expertise, you could say. So some just very top principles before I go into like the how of this. It is a cognitivist perspective. We think of knowledge as mental representation, but yet we agree or sort of value that not all knowledge has to be like explainable in words, verbally like encoded. And we sometimes use this knowledge star to kind of highlight to others that we are not thinking of knowledge as justified true belief. We believe it's really important to look at the details of what people are saying for the reason of, you know, what I showed earlier, that you know, it's important to understand this individual variation that can happen even within an interview. So the content, we think, is very important. Intuitive knowledge itself is, across domains, really important and valuable to study. Similar to interaction analysis, actually, it's accountability to what's happening in a moment in a process, you know, is important. We're not trying to catalog what does somebody know and take it out of you know, video data of people reasoning through situations is the kind of data that we're looking at. And yes, the last one, that contextuality is pretty much, you know, this is a key to, we expect this. We expect to see that this phenomenon of shifting explanations can happen, and the question is then why and how, but it's, you know, important to, name that as an expectation of this perspective. Kind of counter principles, if you will, we were trying to sharpen a little bit, and one of the first counter principles that we described was that, you know, often when you try to come up with a way of describing what somebody knows, you might start from how an expert reasons about that, and then see what pieces of that the student has, and we reject that kind of framing. We want to study starting from what we see people use in the context and develop a language around that, and it might look really different than it might look really different than other expert descriptions of reasoning in the context. We use new terms like phenomenological primitive, or coordination class is another one that kind of came out of this work, and there are others since then, to be more specific about the phenomenon that we're talking about, as opposed to using a term like concept or belief or theory. Like, you can gloss or in conversation use these terms, but part of our method is to eventually come up with more, we think, close to what students are noticing and what they're inferring, how to have a language that's describing their reasoning from what we infer of their perspective. So it is third person, but it's also trying to not overlay a language that doesn't try to take the perception of the individual into account. So it requires talking about knowing in a different way. And the last one is more related to the modeling concerns, not, in cognitive science, there are ways of modeling thinking using, production systems or terms that are very general and that don't really rely upon the content of what people are saying. And so we would say that would be, they're all models. We're all building models, but those models are not as useful for our purposes. So with that said, I wanted to organize the next part of the talk using this framework for comparing methodologies that Bruce Sharon and Taylor Martin came up with in a paper a couple years ago. And so they thought, okay, if we were to compare methodologies, what are some dimensions that we might, try to articulate and talk about the methods with respect to each other? So the first would be just the empirical setup of the method. What are you, so in the case of thinking and learning, what are you trying to study? What are the instances? Are you looking at interviews, discussions, natural contexts? Capture, so what's captured exactly? Do you capture just by taking notes on what you see? Do you do interviews? Is the capture of the interview? Do you do video of learning interactions, for example? And then what do you do once you have the instance? How do we attend to what's captured? Do you only care about whether the answers were right or wrong, or are you looking at everything that the student or the subject is saying and doing? Do you start out with a set of codes and then well, that's next, but do you reduce the data, generate a set of codes, or what is the outcome? What is the way that you're reducing the data at that point? And then the next two, pattern finding, what kind of questions are you asking? So these are not meant to be about knowledge analysis per se, because I won't talk about exactly all of these in that case, but some possibilities for kinds of patterns you might look for would be correlations in codes, or do you look for transcripts and do a transcript analysis of patterns that you see there? And then finally, which has come up a lot this morning in thinking about sort of the describing the results of the analysis to others, how do you represent all of this? You can't obviously represent your entire process using journals as we know them today, although maybe in the future we have some different possibilities for that, but how do we report the result of the analysis? So I want to first take us through, just at a general level, knowledge analysis for each of those dimensions, and then I had a specific case of analysis that I wanted to do that for. So our goals, as we said before, we're trying to understand content and form of individual knowledge, and thinking together with an individual about how they reason about the phenomenon. So it's very important to kind of state up front, this is not about assessing everything that they know. These interviews about a specific topic, at the end of the day, we're not trying to say, I now understand everything that they know about mechanics, or even a very specific topic like, ball tosses. A characteristic concern, as we said before, is this contextuality. We are trying to elicit that kind of differences in their ways of thinking. So we assume that, what they say or do is this window that we can, that is part of our empirical setup, and that we could do both things like clinical interviews, where we have more control, or we can look in naturally occurring context as well. And those two setups speak to each other. I think DeSessa would, or he has talked about the ways that his earlier work on the interviews influenced the later work that he did in classroom episodes, and that he wouldn't have been able to do the same analysis of classroom episodes without the earlier clinical work. So we don't only want to stay in the clinical context, but there are affordances and constraints of both. Right, and so in trying to set up these situations, what it is helpful to do is to think about how we can ask them to think about the same issue multiple ways, maybe using multiple representations, maybe asking them many different times to think through the same event or idea, or as in the case of the ball toss, may deliberately prompt other ways of thinking to see those subjects' receptivity to that. So in terms of capture, video and audio records are the most common for us, but we also are interested in interviews where they might be working with like a computer representation, or might be creating drawings, and so those also become part of the corpus of what we analyze. So in the capture phase, if we wanted to see how students are using a computer to learn about something, and they're talking with it, and it's part of the interview, we need to capture, how they are interacting with the computer. Like if we had only like the screenshot of what was happening there, we would miss an important aspect of the data to analyze later. So just to be aware of that changes a bit what you're trying to make sure is in your data eventually, but it does have implications. So in terms of reduction, and this, I think, was one of the areas that was very interesting in collaborating in the interaction analysis project, was our ways of transcribing initially were somewhat intuitive, and we added things as we thought we needed, and they became consequential, but we didn't really have a system. Interaction analysis and conversation analysis has a lot of work that's been done in articulating ways of capturing the interaction and sort of moving between like the raw data and like a nice representation of it. We're doing this somewhat intuitively, so that was a way that a lot of us tried on and felt was really a very easy and important compatibility between methods, was just to think about how do we make a representation of this experience that is insightful, and not to start out beforehand saying, well, we have to just transcribe every time they laugh, or we have to get every intonation, but to sort of enrich the transcripts using those tools as it becomes relevant, but to know that there are tools out there for that. So this is an area we're very interested in. I think this actually goes into pattern finding. These are heuristics that I had written for myself in doing my first knowledge analysis, was to try to think about, when looking at that schematization or looking at the transcript, how to recognize the knowledge there. And the first was to schematize what I saw using these two questions that I asked myself. What is the subject attending to in a moment, and what are they inferring from that? And then to write that down, instead of they know this, but just to write down those kinds of, to interact with the transcript in that way. and to describe things at a very small grain size so that I'm not, so I can witness the contextuality. If I give too big of a gloss, you kind of cover up things. Right. So these are the types of things that we, look for or that are indications in the data. So, like I said before, reactivity or receptiveness to a new way of thinking. So that's an example of like a reaction that could be very informative for the analysis. If somebody takes something to be, self-explanatory, that's also something I think that deserves attention or note. Affective features, like if somebody's very hesitant in what they're saying, then that might be an area to try to explore more. If they're very confident, and you can look for features like, their pacing and tone and speed, then that's something that, presents a very different profile of understanding. And then also, is there like, what ideas are on the top of someone's head? That's informative as well. What do they choose to say first? It's different than what kind of came out after a lot of conversation. I think that shares features with all of us trying to do these interviews. Those are pretty generic yet important, I think, to state ideas about what to look for. So we look at, again, the issue of selecting the episodes. How do we look across, data and zero in on exactly what we're going to spend so much time trying to understand? So there's this practice of going through and thinking about, what is being said, what do we already know, what theory is there already around this, and going back and forth. I think this might be easier to see in the example that I show, but it's a grounded approach largely that we try to start from the bottom up to think about the theoretical accounts that we're generating. And finally, reporting. It's the usual problems. You have the kind of generic thing that you present at the end, but it emerged from a very long process of analysis. So, there are some criteria that Capone and DeSessa have articulated for the attributions that they made, but it's it's a thing that we all struggle with, I think, in trying to select these specific examples as cases of something and to interpolate between the specific experience described there or analyzed there and something general. So the specific case study I want to give is about understanding fastness. So Parnafez, in an article in the Journal of Learning Sciences, was interested in how representations, and particularly computational representations, supported students' conceptual development. And so her study involved pairs of high school students, just 8 pairs of students, and they were reasoning about simple harmonic motion with both physical oscillators and also this computational representation of oscillation. And so she gave them all of these different means for thinking about that phenomenon. So she gave them these springy rods, physical pendulums, springs, and then she also had designed this simulation of harmonic motion with many different coordinated views within. I'll show a picture in a minute. Okay. And so it was a pretty open-ended study in that she wanted the students to discuss the similarities and differences that they saw between the various oscillators, how they worked. She wanted them to work together in pairs because she didn't want to intervene very much in the interaction. She wanted to capture what they were doing. And so we say in this sense it's naturalistic, but she did, as you'll see in the transcripts, have moments where she came back and refocused them on specific aspects that she wanted them to explain more. And so she did play a part in the interaction as well. But she wanted it mainly to be the kids talking with each other and interacting with these various objects. So the springy rod is like just like a metal ruler that they could, play around with how they positioned it and what effect that had on its motion, and pulling the springs and watching them oscillate and sort of what effect various parameters had on that motion. She gave them, pendulums, so they played with the pendulum, sort of thought about the connections with that, and then finally here she gave them this computational representation where they could change some of the parameters, so it, but it, including the friction and spring constant they could play with, but they would see the effect of those changes in these three modalities. There would be this velocity versus time graph, but also this one that captured more like the frequency and periods, and then this one here that showed more just what the oscillating object, its motion looked like in a kind of schematic way. So she videotaped this with one camera, and she had it positioned so that she could see them talking with each other and capture them playing with the oscillators, and then she moved it so that when they were working with the computational representation, she could see what the two students and also what they were doing. She's described some of this in this paper, this microgenetic learning analysis paper, where she talked not only about the setup, but also sort of like what her method was. So, she looked through all of the data. These were about an hour and a half interview or videos each. And she looked for, through the entire, first she looked at the entire kind of video to find, like similar to what Reid was saying, where you make a kind of content analysis and get to know the data first, just what is in the data. And she thought, okay, one of the issues that I think she knew would be interesting from the beginning is that she's given them all of these different representations of oscillations, so they will have many different ways to think about that phenomenon and how students talk about it. But she zeroed in on this specific term that they were using, fast, and how they used it in different ways, but without really noticing or kind of being too concerned about that. So she looked then at all of the places where they were talking about fastness. And so here's two examples. In the first one, she notices that Rachel is in that part of the transcript thinking about the springy rod context and talking about fastness as vibrations per unit time. And then there's a context where she's talking about the pendulum, and she thinks about it instead as as this distance that the pendulum has to move, and it has a shorter distance to move, then it has to go faster to kind of compensate. And so she's thinking about and using this term fastness in just a kind of a generic way, but not realizing these are technically different. And so this multiple undistinguished ways of thinking about fastness was something that she was interested in, and then she noticed, secondly, that when they worked with the physical oscillators, it didn't seem to get problematized for them, yet when they had the computational medium, then they began to be able to play with it. That's when the distinguishing of those meanings started to happen. So for example, here is a place where they're using the simulation, and they first think about, they first hypothesize the slower the oscillator goes, the lower the graph is, and also the further apart the bars are. And they did a little experiment that corroborated that, but this didn't help them kind of challenge the ways they were talking about fastness, because they had changed the spring constant, and that changed both the frequency and also the velocity. And so here, they controlled just the displacement, and that is something that allows them to sort of see the difference. It's a parameter that affects the linear velocity only, not the frequency. And so that was like the first place where they started, being able to distinguish what was happening. So she was interested at that point in then the role of the representation in supporting their kind of distinguishing of meaning. And so the way the analysis proceeded then was to look for patterns in the role of the representation. What work was it doing? So she came up with these mechanisms or like places where she saw the representation kind of allowing this kind of distinguishing, sort of making them aware of the difference in the way they were talking about fastness. And so that's sort of going towards reporting the results. That's the kind of result that she reported then, were those moments where they had undistinguished ways of talking about fastness, and then the way that the representation helped them to reconcile and be aware of them. So, right, okay. So this same data that Parnafez analyzed first from a knowledge analysis perspective became like the core data that was used in one of the collaborative projects that we did together in our knowledge analysis and interaction analysis meeting. And so the KA analysis started from one of the kind of theoretical lines that grew out of knowledge analysis coordination class theory that is about, what information people are reading out in order to like understand their world. And that was the way her analysis was framed. It ended up in the reporting of it using that theoretical language as a way to talk about what the students were doing and coordinating eventually. But the new goal, when this team, which involved Orit Parnafez as one of the authors, and then Joshua Danish at Indiana University, and Noel Enyedi at, well, now he's at Vanderbilt, right? Yeah, but then he was at UCLA. They worked together, and the new focus of the analysis was thinking about how they established intersubjectivity in their reasoning processes. So they, and the knowledge analysis that they had done became instrumental in doing the intersubjectivity analysis. So they built upon the previous analysis to kind of develop their combined one. So they described this also in their chapter, sort of their process, and I thought it could be interesting for us in thinking about how to combine the methods. Their first step was to just together review the data and explore how the system, the two girls and the computer simulation, engaged in the task. And then to think about critical points of change, and so to think about parsing the interaction into consequential subparts. And this was in terms of either their knowledge or the nature of the interaction, or maybe both. But they engaged in that work afresh together from those, with those goals in mind. And then they conducted separate passes at the knowledge analysis and then the interaction analysis. And then the third team member attempted to create an initial integrated analysis using both methods. And it was the third person happened to be somebody who had kind of their foot in both camps and was able to kind of see the important convergences. So this was a kind of interesting thing that they discussed in the chapter, was that before they had done the work of integrating the perspectives, it wasn't that the knowledge analysis people didn't care about interactions, it's just that they didn't have any technical way to really do that analysis very, very well, and vice versa. Interaction analysis folks cared about the content and were kind of bringing it into the analysis when it was consequential, but that wasn't really what that method was focused on. And so, they were opportunistically, even in the separate analyses, already doing a kind of intuitive version of the other one. And And so the results together, I think, was a nice example that really, highlighted the intersubjectivity, which was something that had been taken for granted in the knowledge analysis completely, but it sort of showed in particular how that was established. So I think it was a good example of where the result was something more than each of the separate pieces by themselves. So that was a chapter in the book, which if you want to see the actual details of the analysis, I just wanted to schematize sort of the process of that here. But I think it's a good place maybe to take questions. And
thank you.
yeah.